Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Part 20 with matplotlib tutorial. So in this video we will discuss about how to customizing the color and styles in matplotlib. So here we will discuss about all these 11 things based on customizing the color and styles in matplotlib. Let's get started. Alright, first we will know about how to defining your own colors. Let's see here, the default colors used by matplotlib are rather bland. We might have our own preferences of what convenient colors are. We might want to how to customizing the color and styles in matplotlib have figures that follow a predefined color scheme so that they fit well within a document or a web page. More pragmatically, we might simply have to make figures for a document that will be printed on a black and white printer. In this recipe, we are going to see how to define our own colors. There are multiple ways to define colors in matplotlib. Some of them are as follows. First, triplets. These colors can be described as a real value triplet: the red, blue, and green components of a color. The components have to be in the 0, 1 interval. Thus, the Python syntax will code a pure, bright red, while appears as a strong pink. Number 2, quadruplets. These work as triplets, and the fourth component defines a transparency value. This value should also be in the 0, 1 interval. When rendering a figure to a picture file, using transparent colors allows for making figures that blend with a background. This is especially useful when making figures that will slide or end up on a web page. Number 3, predefined names. Matplotlib will interpret standard HTML color names as an actual color. For instance, the string red will be accepted as a color and will be interpreted as a bright red. A few colors have a one-letter alias, which is shown in the following: B for blue, G for green, R for red, C for cyan, M for magenta, Y for yellow, K for black, W for white, etc. HTML color strings. Matplotlib can interpret HTML color strings as actual colors. Such strings are defined as #RRGGBB, where RR, GG, and BB are the 8-bit values for the red, green, and blue components in hexadecimal and gray level strings. Matplotlib will interpret a string representation of a floating point value as a shade of gray, such as 0.75 for a medium light gray. Alright, now we will see an example. Setting the color of a curve plot is done by setting the parameter color, or the equivalent shortcut C, of the pyplot.plot function as follows. Alright, let's execute it. In this example, we generate 5 sets of 50 samples from a normal distribution. For each of the 5 sets, we plot the estimated probability density in light gray. The normal distribution probability density is shown in black. There, the color is coded using the shortcut for black, that is K. Now we will know about using custom colors for scatter plots. We can control the colors used for a scatter plot just as we do for a curve plot. In this recipe, we are going to see how to use the two ways to control the colors of a scatter plot. The scatter plot function pyplot.scatter offers the following two options to control the colors of dots through its color parameter, or its shortcut C. First one is common color for all the dots. If the color parameter is a valid matplotlib color definition, then all the dots will appear in that color. Second one is individual color for each dot. If the color parameter is a sequence of a valid matplotlib color definition, the ith dot will appear in the ith color. Of course, we have to give the required colors for each dot. Let's see the example. Alright, now you can see the output. Now we will see another example. So in this example we will use a data set, so here we show you the data set. The data set is called dataset.text. Now see here, each point of the data set is stored in a comma-separated list of values. The last column that gives the label of each point is a string that can take three possible values: iris virginica, iris versicolor, and iris vertosa. We read this file using numpy's numpy_load_text function. The color of points will depend on their label, and we will display them with just one call to pyplot.scatter. So let's see the example. First we will declare the label. Alright, let's execute it. Now see here, for each of the 3 possible labels, we assign one unique color. The colors are defined in color set and the labels are defined in label set. The ith label in label set is associated with the ith color in color set. We convert the list of labels, label list, to a list of colors color list, with a list comprehension. We then need just one call to pyplot.scatter, to display all the points with their colors. We could have done this with 3 separate calls, but it would require more code for no tangible gain. It's possible for 2 points to have the same coordinate and yet have a different label. In such a case, the color shown will be the color of the latest point drawn. Using transparent colors, the colors of overlapping points will be blended together. Now we will see another example. Just as the color parameter controls the color of the dots, the edge color parameter controls the color of the edge of the dots. It works strictly for the color parameter. You can set the same color for each dot edge or control the edge color individually. Let's see the example. Now you can see the output, color of the edge of the dots. Now we will know about how to use custom colors for bar charts. Bar charts are used a lot in web pages and presentations where one often has to follow an established color scheme. Thus, a good control on their colors is a must. In this recipe, we are going to see how to color a bar chart with our own colors. In the previous video, which is part 19 of data science, we have already seen how to make bar charts. Controlling which colors are used works the same as it does for curves plots and scatter plots, that is, through an optional parameter. In this example, we load the age pyramid of a country's population from a file as follows. Let's execute it. Now you can see here, the pyplotbar and pyplotbar functions work strictly like pyplot.scatter. We simply have to set the optional parameter color. The parameter edge color is also available. Alright, now we will see another example. In this example, we display a bar chart and color the bars depending on the values they represent. A value in the 0 to 24, 25 to 49, 50 to 74 and 75 to 100 range will appear in a different shade of gray for each bar. The list of colors is built using a list comprehension. Let's see this. Alright, let's execute it. As you can see here, colors for bar charts. And one more thing, here we using randint function. As you can see here. Alright, now we will know about custom color for pie chart. Like bar charts, pie charts are also used in contexts where the color scheme might matter a lot. Pie chart coloring works mostly like in bar charts. In this recipe, we are going to see how to color pie charts with our own colors. The function pyplot.py accepts a list of colors as an optional parameter, as shown in the following script. Alright, let's execute it. Let's see here, pie charts accept a list of colors using the colors parameter. Beware, it is colors, not color. However, the color list does not have as many elements as the input list of values. If there are less colors than values, then pyplot.py will simply cycle through the color list. In the preceding example, we gave a list of 4 colors to color a pie chart that consisted of 8 values. Thus, each color will be used twice. Alright, now we will know about how to use color maps for scatter plots. When using a lot of colors, defining each color one by one is tedious. Moreover, building a good set of colors is a problem in itself. In some cases, color maps can address those issues. Color maps define colors with a continuous function of one variable to one value, corresponding to one color. Matplotlib provides several common color maps, most of them are continuous color ramps. In this recipe, we are going to see how to color scatter plots with a color map. Color maps are defined in the matplotlib CM module. So here we import that module. This module provides functions to create and use color maps. It also provides an exhaustive choice of predefined color maps. The function pyplot.scatter accepts a list of values for the color parameter. When providing a color map, with the CMap parameter, those values will be interpreted as a color map index. Let's see the example. Let's execute it, and see the output. As you can see here, in this script, we plot a spiral of dots. The dots are colored as a function of the angle variable, taking the color from a color map. A large set of color maps are available in the matplotlib CM module. The HSV map contains the full spectrum of colors, which makes for a fancy rainbow theme. For scientific visualization, other color maps are more appropriate, taking into account the perceived color intensity, such as the PU-OR map. The same script with the PU-OR map will give us the following result. Now we will know about how to use color maps for bar charts. The pyplot.scatter function has a built-in support for color maps. Some other plotting functions that we will discover later also have such support. However, some functions, such as pyplot.bar, do not take color maps as inputs to plot bar charts. In this recipe, we are going to see how to color a bar chart with a color map. Matplotlib has helper functions to explicitly generate colors from a color map. For instance, we can color the bars of a bar chart with the functions of the values they represent. Now we will use the matplotlib CM module in this example just as we did in the previous example. This time, we will directly use a color map object rather than letting a rendering function use it automatically. We will also need the matplotlib colors module, which contains the utility functions related to colors. Let's see the example. So here we need to import matplotlib color module as COL. Now see here, we first create the color map CMap so that it maps values from the 0 to 99 range to the colors of the matplotlib CM binary color map. Then, the function CMap to RGBA converts the list of values to a list of colors. Thus, although pyplot.bar does not support color maps, Using color maps does not involve complex code, there are functions to make this easy. Now we will know about how to controlling a line pattern and thickness. When creating figures for black and white documents, we are limited to gray levels. In practice, 3 levels of gray are usually the most we can reasonably use. However, using different line patterns allows some diversity. In this recipe, we are going to see how to control line pattern and thickness. As in the case of colors, the line style is controlled by an optional parameter of pyplot.plot. So as you can see here, the output. Now see here, in this example, we use the line style parameter of pyplot.plot to control the line pattern of 3 different curves. The following line styles are available: solid, dashed, dotted and dash dot. Now we will see another example. Line style settings are not limited to pyplot.plot, in fact, any graphics made of lines allows such settings. Moreover, you can also control line thickness. In this example we will know about the line style with other plot types. The line style parameter is available for all the commands that involve line rendering. For instance, we can modify the line pattern used for a bar chart as follows. As you can see here, we mentioned 4-side dashed line. So now you can see the output. Now we will know about line width. Likewise, the line width parameter will change the thickness of lines. By default, the thickness is set to 1 unit. Playing with the thickness of lines can help to put emphasis on one particular curve. The following is the script to set the thickness of lines using the line width parameter. Let's see here, in the following graph, which is a result of the preceding script, 64 estimated Gaussians PDF, probability density functions, are estimated from 50 samples and are shown as thin gray curves. The Gaussian distribution used to draw the samples is shown as a thick black curve. Now we will know about how to controlling a fill pattern. Matplotlib offers fairly limited support to fill surfaces with a pattern. For line patterns, it can be helpful when preparing figures for black and white prints. In this recipe, we are going to look at how we can fill surfaces with a pattern. Alright, now you can see the pattern. So now we will know about controlling a marker style. In the previous video, we have seen how we can display the points of a curve as dots. Also, scatter plots represent each point of a data set. As it turns out, matplotlib offers a variety of shapes to replace dots with other kinds of markers. In this example, we are going to see how to set a marker style. Let's take a script that shows two sets of points with two different colors. Now we will display all the points in black, but with different. Let's execute it. In this script, we set the color of both scatter plots to black. Using the marker parameter, we specify a different marker for each set. Now we will see another example. The marker style is also accessible for pyplot.plot, using the same marker parameter. Using one marker for each data point can be a problem as it will display more points than we want to. The markavary parameter allows you to display only one marker for every n points. Let's see this. Alright, now you can see the output. Now we will know about controlling a marker size. As seen in the previous recipe, we can control the style of markers. Controlling their size also works along the same lines. In this recipe, we are going to see how to control marker sizes. A marker size is controlled in the same way as other marker attributes. with a dedicated optional parameter. Let's see this. Now see here, in this example, we display two sets of points of different sizes. The marker size is set by the parameter s for pyplot.scatter. Oddly enough, it sets the surface area of a marker and not its radius. Because the sizes are the actual surface areas and not the radii, they follow a quadratic progression. The markers that are 4 times larger will have radii that are 2 times larger. Now we will see another example. The pyplot.scatter function also takes a list as an input for the s parameter, one size for each point. Let's see here, in this script, we drew random points according to a bivariate Gaussian distribution. The radius of a point depends on its distance from the origin. The pyplot.plot function also allows to change the size of the markers with the help of the markerSize parameter. This parameter does not accept a list of values as an input. Now we will know about how to creating your own markers. Matplotlib offers a large variety of marker shapes. But you might not find something that suits your specific need. For instance, you might wish to use an animal silhouette, a company's logo, and so on. In this recipe, we are going to see how to define our own marker shapes. Matplotlib describes shapes as a path, a sequence of points linked together. Thus, to define our own marker shapes, we have to provide a sequence of points. In this example, we will define a cross-like shape. So here we need to import the matplotlib path library. As you can see here we mentioned shape description. All the pyplot functions that render figures with markers have an optional argument, that is, marker. We have seen in the previous recipe that an argument can be a string to pick one of the predefined matplotlib markers. But the marker argument can be an instance of path as well. The path object is defined in the matplotlib path module. So friends, our today's video was up to this. Thanks for watching the video. See you in next video. Please subscribe the channel and don't forget to like and share the video. Thank you.